Okay, assignment 6, part 3. Okay, our first topic is a word problem involving optimizing area by using a quadratic function. So we're still going to use the x equals negative b over 2a and plug back in, but writing the equations a little more work. Okay, so here's the picture, which I'll come back to in 1 second. Here's the questions. I just couldn't fit it all on one screen. So they want you to find the function that gives the area, find the maximum side length, which is x, and then find the maximum area that gives the garden can have. Okay, so this is your x, this is your negative b over 2a, this is plugging in. This is the one that's new, writing the equation. And at least all these problems are similar, so usually all they do is change numbers. So hopefully I give you enough here. If you have a question, take a picture, send it in the chat, and I can get back to you. Or if you need to meet online, that's fine. All right, so we have 440 meters of fencing. So we have a side of a house. So we're only using fencing for 3 sides. Now, typically, I think back like in high school, if we're using multiple variables, we put a y here. But we want everything to have x. Otherwise, this is difficult. So, because I use x here and x here, I have 440 meters to do all 3 sides. So this one will be our total minus x and x. So minus 2x. So I think when you see other problems, all you'll see is that this number changes. Okay, so on the next page, they want the area formula. Well, area is either base times height or length times width. So we're going to go x times 440 minus 2x. I would imagine that would be fine in ALEKS as the answer. I'm going to simplify it, so it should take either. But if you write it like that, it should be fine. So I'm going to distribute the x. And I like putting the negative 2x squared first. So I get a negative 2x squared plus 440x. Okay. So now I have my a and I have my b. All right. So ALEKS should take either of these. And that's the hardest part. So negative 2x squared plus 440x, or the unsimplified version. Okay, so for part B, I'm going to do part B over here. That's x equals negative b over 2a. So negative 440 over 2 times negative 2, which is negative 4. So x is 110. And because these are ALEKS problems, they should come out nice. So we get 110, and then we need a calculator for this part. We just plug the 110 in our calculator. Okay, I'm going to put that in my calculator, see what we get. Negative 2 times 110 squared plus 440 times 110. And I got 24,200. So once you get the equation, this is the same thing we did before, just bigger numbers. Okay, so the x is, because they're asking for a maximum and this opens down, it's a maximum. You don't have to worry about that. Whatever they ask for here is correct. So you can just do the negative b over 2a. It's going to work. They won't ask you for something that doesn't exist. Okay. All right, and we got another type of question, which is once you know the setups are basically all the same. So that was question 1. Here's question 2. They once again want us to write an equation for the total area. So I'm going to put up a total area. Okay, let me just go to that page for a second. So they're asking you for total area, x that minimizes. So this is going to be a min problem, but it's still the exact same thing. Negative b over 2a, plug it in. So you don't have to differentiate between maximize, minimize. And this will be the y value. All right, so it says we have wires connected two pieces, and each piece is bent and formed into the shape of a square. That's key. So when you see this, I think when in ALEKS they just changed this number. These are all x's. All right. So now, this is the way I think about this. What's the amount left over for the small square? Well, I started with 48 and I subtracted 4 of these x's. Okay. But this is how I think about it. Each side, because we have 4 sides and this is what's left over, we're going to take 48 minus 4x and divide it by 4, which is 12 minus x. So each side here is 12 minus x. Okay, so you do the leftover, and because this is a perfect square, you divide it by 4. So 48 divided by 4, 12. 4 minus 4x divided by 4 is just minus x. Okay, so now we can make our area formula. So the area of this square, base times height or length times width, is x squared. Now this one's a little bit uglier. Plus, we're going 12 minus x times 12 minus x. Okay. And I just want to see if I can just clip that into the next page. Let's see. I think I have a way around it. Had to. Okay. So the only thing here is that we have to simplify this. All right, so remember 12 minus x times 12 minus x. You have to FOIL that. 12 times 12 is 144. 12 times minus x minus 12x. Negative x times 12 minus 12x. Negative x times negative x plus x squared. All right. So that was this whole part. And I have to add another. I'm going to remember there was an x squared in front from the original. So I get 2x squared. This is the hardest part. Minus 24x plus 144. Okay. So here's our A and here's our B. So now once we get here, this shouldn't be bad. So for this one, we get negative b. So negative 24 is positive 24 over 2 times 2, which is 4. So that's 6. So the length x that minimizes this area is 6. And then we're going to plug 6 into this equation to get the minimum area. So I'm not going to write it out this time. So it's 2 times 6 squared minus 24 times 6 plus 144. And that's 72. So the area, when we plug 6 in, gives us 72. Okay. So the hardest part is this right here. And it should accept this answer. This is your area simplified. It should accept either, but you need this in order to do the negative b over 2a and then plug it back in here to get your 72. Let me just make sure everything looks good there on my calculator. Plus 144. Yep. Okay. All right. So now we're at an easier part. Domain and range of the graph of a quadratic. So I'll just tell you, this goes up and out forever. This goes up and out forever. So you have to use like imagination, like pretend it's going this way, pretend it's going this way. So it's always going to hit all x's. So the domain of a quadratic in interval notation will always be negative infinity to infinity. And we always use parentheses with infinity because you can't count to infinity. Now, the range is where you have to think a little bit. Okay, so this opens up. So the bottom of our range is, because it opens up, the bottom is this y value right here, -4. So the range is, the lowest number is -4. And because it's part of the curve, we use a bracket, which means the number is included. And then for the range, it goes up forever. So up forever means infinity, and we always use a parenthesis. So for all these problems, domain's going to stay the same for quadratics, for parabolas, quadratics. All right, so that was number one. Let's check out number two. So if you want, pause this one, try it. I'm going to continue on with the video. All right, so here is our max now. That's our highest point, which is once again the y value. So we already know domain. I'm just going to write the d there. I'm just write a d there. Domain. That's negative infinity to infinity. That's all the time. So range. Usually domain and range, we like to put these in order. I don't know how picky Alex is. So you want to start with the bottom. Well, this goes down forever. So the bottom is negative infinity. And the top, okay, these values are connected. The top y value is 4. And the top of the curve, it's part of the curve, is you always use a bracket. So it goes negative infinity to 4. And that concludes this video.